Hi, in this video I'm looking at finding the equation of the tangent and normal to this equation here, x squared on 16 plus y squared on 36 equals 1 at the point -2, 5.2. So the tangent and normal both require us to have the gradient because the tangent is the equation of the gradient at that point and the normal is perpendicular to the tangent at that point. So the first thing we need is gradient, and gradient means we need to find the derivative of this equation here. So we've got to start off with our x squared on 16 plus y squared on 36 equals 1, and we need to find its derivative. And to do that, we're going to do implicit differentiation. So what we're going to do is we're going to differentiate both sides. So I'm going to find dx of the left-hand side and dx of the right-hand side. And that means that I'm going to have dx of x squared on 16 plus dx of y squared on 36, which needs to equal, well, ddx of 1 is 0, because the derivative of a constant goes down to 0. So let's start off with our ddx of x squared on 16. So we want to derive x squared on 16 with respect to x. So that means that we're going to multiply by 2 and subtract 1 off the power, and that's over 16. So that means that we are left with x on 8. If we have a look at our dx of y squared on 36, we can't really do this because there's no y here. But we can write this as a chain rule, and it's the chain rule. So for ddx, we're going to have d with respect to y, because that's the variable I've got, of our equation, y squared on 36. But that means I need to cancel out that dy and get a dx back, so I've got to also have multiplied by dy dx. So that's going to be the derivative we're going to do. So dy of y squared on 36 is going to be 2y on 36, but we're multiplied by dy dx. And 2 on 36 gives us a 16th, so we've got y on 16 times dy dx. So now if we go and substitute those into our equation over here, I've got ddx of x squared on 16, which we said was x on 8, so I've got x on 8, plus ddx of y squared on 36, which using the chain rule we worked out to be this over here, y on 16 times dy dx, and that equals 0. So now to find our derivative dy dx, I just need to isolate dy dx. So I'm going to minus an x over 8 from both sides. And so that's going to leave us with y on 16 dy dx, which is going to be equal to negative x on 8. And then we're going to divide both sides by y on 16, so we'll divide by y on 16. So that means that dy dx is going to be negative x on 8 multiplied by 16 on y. And so that means that we are left with dy dx equals negative x, 16 divided by 8 is 2, so we've got negative 2x on y. So now we have our derivative, dy dx equals negative 2x on y. So now if we want to go and have a look at finding our normal or our tangent, let's start with the tangent. So for a tangent, we want the equation of a straight line, so we're going to use our rule, y take y1 equals m outside of x take x1, because we have our point up here, negative 2, 5, 2. So that's x1, y1. So x1, y1 is negative 2, 5.2. But we also need m, our gradient. And that's going to be the value of dy dx at our point 2x on y. So we're going to have negative 2 times by negative 2 if we substitute into this rule, negative 2 for x, and we're going to divide by y, which is 5.2. So we're going to have 5 of 5.2. And if we work that out as a fraction, that gives us a gradient of 10/13. So we have our point, we have our gradient at that point. So now we can substitute into our rule. Y take y1, well y1 is 5.2, equals m, which we just worked out to be 10 on 13. Outside of x, take away our x1, which is negative 2. So now we just need to make this be a nice neat equation. So this is going to give us y take 5.2 equals, well, we'll open up this set of brackets. So we're going to have 10 on 13x, and 10 on 13 multiplied by positive 2, which is going to give us plus 20 on 13. So now I'm going to put this into our general form of a linear equation. So I'm going to minus off the 10x on 13, and I'm going to minus off the 20 on 13 from both sides. So that's going to give us negative 10 on 13x plus y minus 5.2 minus 20 on 13, and equals 0 is what's left on the right hand side. And so we're going to have negative 10 on 13x plus y, negative 5.2, take 20 on 13, leaves us with negative 438 on 65, and that equals 0. And now what I'm going to do to get rid of both of our negatives and these fractions, I'm going to multiply everything by negative 65. And so that leaves us with the equation of, well, the positive 10 will be multiplied by negative 10 will be multiplied by negative 65 on 13, which gives us 50x. The y will be multiplied by negative 65, so we have minus 65y. And this negative will cancel out with this negative, the 65s will cancel out, so we're just left with plus 438 equals 0. So that is the equation of our tangent. So what we need to do now is get the equation of our normal. Now the normal, we just need to get our gradient, which is going to be the negative reciprocal of this, so it's going to be negative 13 on 10, and go to our same rule. Y take y1 equals m, outside of x take x1. So we're going to have y take 5.6 equals our new m, which is negative 13 on 10, outside of x take negative 2. So we're going to have y take 5.6 equals, and if we open up this bracket, we're going to have negative 13 on 10x, and multiply the negative 13 on 10 onto the positive 2, so we're going to have negative 13 on 5. Rearranging again into general form, so we're going to add 13 on 10x, and we're going to add 13 on 5, so that way we have 13 on 10x plus y minus 5.6 plus 13 on 5 equals 0. And then we'll perform this subtraction. Negative 5.6 plus 13 on 5 happens to be negative 13 on 5. So we're left with 13 on 10x plus y minus 13 on 5 equals 0. I'm then going to multiply everything by 10 to get rid of our denominators. So 13 on 10 times 10 leaves us with just 13x. Y times 10 is plus 10y. And negative 13 on 5 times 10 leaves us with 2 times 13. So we have minus 26 equals 0. And that is the equation of our normal. And so we're done. So if you ask for tangent or normal, that means we need derivative. To derive this, I need to use implicit differentiation, which means I derive everything by x. That means I might be able to do an easy derivative, or it might mean I need a chain rule. And so then we rearrange and get our derivative, use our equation of a linear line with point and gradient to get our tangent equation, and take the negative reciprocal of the gradient for the normal, and get our normal rule as well.